Well, welcome everybody to my Eclipse talk, Trace Compass Cloud, and it's about the Trace Compass migration towards Theia. So in this presentation, I will start talking about what is tracing to set the stage, give a little overview what Trace Compass does, and then we go into the migration steps, the new architecture with Theia and its implementation in the extension. I give a short demo, and at the end, I will go into the project status. So what is tracing? So tracing is a troubleshooting technique where developers put trace points into their code, they instrument their code, and put information about the program and source code location in that trace point. And the tracer then is able to collect this data, and there are different techniques and there are different traces out there. In Linux, very common tracer is the LTTNG. ftrace is part of the kernel, as well as perf. And the characteristic of a good tracer is that it has low overhead, meaning if you run the execution, it doesn't changes the behavior of your application a lot. So what is a trace? Trace is a sequence of events collected on the execution path. So your program runs, and when it hits a trace point, an event is enabled, it collects the information. So an event has a timestamp, a type, content, and information about the program, so you can understand your program execution. When you want to analyze it, so you have created a trace or a set of traces. You need to parse it first, get it from the input format in a common format, and then you can print it out, the stream of events. Just look at it in a text editor, for example, or having some tools to look at the raw data in a table. Then you can analyze it further. You can look at timestamp, the specific content, and see and pull out information about the execution and make sense out of it. Often it's required to store some persistent information, which makes it then easier to query that information in certain visualizations, certain views. And yeah, not everything is loaded in RAM if you store it on disk, for example. Eclipse Trace Compass, it's a project at the Eclipse Foundation, open source, of course, and it's a tool to provide a way to solve performance and reliability issues, and it's reading traces and logs of a system. It could be from one application or from different places of the application, different layers, and so on. And then it creates different views and graphs, metrics, and which is easier to understand and than just looking at a huge text dump. Yeah, Trace Compass is around for a while, has a very good support for Linux traces and open source, and it's used quite a bit in embedded systems, for embedded systems. However, if recently we get some questions from users or potential users where we present the capabilities. So some users ask if it can run in a browser. Often there is a requirement to look at it from a browser, click on a link and get the results and graphs from there. Also, Jenkins, same idea. You run something in Jenkins and you want trace analysis results seen in Jenkins. And both things are not really possible with a desktop application. Can we run it in a headless mode, which means start analysis and some pre-processing without the UI? And it's kind of supported with Eclipse is supporting in Trace Compass, but still UI dependencies are there. What about custom graphs or custom libraries? People, when thinking about visualization, you think about JavaScript libraries and D3. But being an Eclipse application, Trace Compass is bound to SWD and JFace. And so integration with more modern libraries is not possible or not easily possible. And last question, which I have heard recently, is about, can it integrate with Theia or VsCode? So have an integrated solution with these new IDE types, and that's not possible because it runs on Eclipse. So we were thinking about how can we solve that situation. So we thought the client-server architecture can help to provide these functionalities, and also being able to reuse existing implementations and not having to recode everything. So on the bottom, you would have a trace server backend, which is responsible for parsing the traces, event processing. It has all the domain-specific logic for the visualization then later on. And it provides ways to serialize the data to the clients, either locally or over the network. And visualization front end can then take the data from the server and visualize it in various graphs. So we started a journey to re-architect Trace Compass from a monolithic application. We had core components already without UI, as well UI components. However, we had to move some logic from UI implementation to core. Then we packaged all the Trace Compass core plugins, including Eclipse platform core plugins without UI, into a trace server backend, added trace service with endpoints to query, and that will be a standalone application that can be queried. To exchange the data from a client to the server, we defined a trace server protocol, which gives the information and a standardized way to get the data from the front end to the back end. Looking at the trace analysis workflow, it's very similar as before. So the trace server backend takes care of trace reading, analyzing the traces, create some intermediate storage and information. But on the front end side, it's separated. It's a different process, a different application, and it's querying the information over to TSP. The trace server protocol, we implemented it as a REST API. It's on GitHub at the moment and can be followed there. We are revising that protocol at the moment and improve the documentation around. So there's quite a bit of effort put in to improve the documentation and definitions. So after that effort, we will have something that shows what is currently available in our solution, but also things that will come up in the future. To provide a new front end, we looked into some web frameworks, and Eclipse Theia is one of them that can be used to create UI applications. It's an extensible platform, uses modern web technologies, and it allows to integrate with IDE workflow. So you can do your code editing, your debugging, and the trace analysis in the same environment. So it was very attractive for that. Deployment-wise, it can run into the browser and the desktop. And it's open source and has a very good community around. Let's look at the architecture with Theia. So on the left side, you see a Theia application. And inside, yeah, you have the Theia platform that we use. And then we created an extension, the Theia Trace Viewer extension. And we have different modules or components in there that we develop. So the TSP TypeScript client is a client-side implementation of the Trace Server protocol. It can be, it is used to communicate to Trace Server backends, and it can data out according to the TSP. It can be integrated in any relevant web applications. We created a trace viewer base. That component is responsible to manage traces and trace sets, and it uses the TypeScript client to communicate with the server. The trace viewer react components on the other side is providing the actually graphing and views and widgets. It's based on React, and it communicates through the TSP TypeScript client with the Trace Server backend. We also creating a timeline chart. That's a Gantt chart type library. It allows handling huge amount of data. It supports lazy loading, has support for nanosecond precision. And yeah, it's used to visualize state machines over time. And of course, we use reuse and leverage third-party libraries for other visualizations. Recently, we added NPM packages. So from the Theia Trace Viewer repository, we are able to create the Theia Trace Viewer extension. It's available there. And if you're interested to add that into your Theia application, just add that dependency to the package.json, and then you can connect to a server. You see here a link to the Trace Compass Trace Server reference implementation. So you get similar functionality than Trace Compass itself. Then we have the other two components also available on NPM, the Trace Viewer base and the Trace Viewer React components. One thing I want to highlight about these two components is they're not dependent on any Theia APIs. So they can be used in other applications, in other web applications. So independent of Theia. So very useful. And I will show an example later on how we use that. Yeah, timeline chart and the TSP TypeScript client I already mentioned in the architecture diagram. And now I would like to give a demo about the Theia Trace extension. So from the source code, I built, I'm able to run it in the browser, but I also can package as an Electron AMP. So this I will use now for the demo. And this example application gives, it packages other features available for Theia, like debugging, code editing, and so on. When you open it, you will see the trace viewer icon on the left, and there is a trace viewer panel. Then a button is available if no trace has been opened beforehand. So you can use that to open a dialog, navigate on your file system, and open a trace. It's also possible from your file browser. So if you're in a workspace and you generated some traces, like in my example, I have a few located under here. I used LTTNG to generate these traces. And with the context-sensitive menu, you can open it with the trace viewer. So if you do that, a few things will happen. It will connect to the trace server. and we'll post the traces. In this case, it's a set of traces consisting of a Linux kernel and a user space trace, and it will upload it. And for that trace, there are different visualizations available, and all that information that is shown there is coming from the trace server. The front end actually doesn't really know what type of trace it is. The trace server dictates what is available. So we have an events table. So that events table shows the raw data of the trace sorted by timestamp. It's a virtual table, so not the whole trace is loaded in memory. When you navigate in the trace and you're out of the cache, it will go back to the backend and reload more data and discard the previous loaded cache. We have a few functionality, searching capabilities. So by typing, it highlights already the visible ones, and then it continues. And if it gets out of the cache window, it will load more data from the backend. Another interesting, and if you're a little bit familiar with Trace Compass, you see resources view, which shows you the DSP CPU states over time. So when you can follow what is running on a given CPU, and analyze what's going on. You have a tooltip available for each state, gives you more information, and if you click on that, you have an id property window populated with the same information. There's highlighting possible. You can zoom with mouse or keyboard. So there's quite a bit of user things implemented. Another interesting view is a flame chart that analyzes the user space trace. And the interesting part of that one is that it shows the call stack over time. The trace has information of function entry and exit. And with that, we were able to show the call stack that at a given time when your program is executing. So very useful view if you analyze your application. In the future, we will provide also the function duration statistic, but that's not available at the moment. We have a few XY charts also available. CPU usage is one of them, histogram. So it gives you the total usage when you open it, but you can then look at different processes and add that information. So if I look at Java, that will be added to the view. Histogram is another one. Event density views you can rearrange as you like, and a few buttons, helper for zooming and going back to the full trace range are also available. If you're finished with analyzing the trace, you can close the views and the trace itself. So in a front end, no visualization is there. But if you want to also remove it from the server, you can do it with the context-sensitive menu. All right, that was my demo of the tool. Back to my slides now. So project status. The Theia trace extension is developed on GitHub. That's the main repository. Development is ongoing. We have a lot of work being done at the moment. We do the project planning inside this one. And if you have to touch other components like the timeline chart or the TSP, which are different repositories, we manage that from here, and then we link new trackers in the respective packages, repositories. And from that one, we create the NPM packages for Theia Trace Viewer, the base and the React components. End of the year, we plan a minimal viable product release that gives a good amount of features for Linux use case. I would like to mention a Python client as well. So tsp-python-client, it's like the TSP TypeScript client that implements the TSP, but in Python. It can be used to automate analysis and doing headless mode. We used it also for rapid prototyping and testing a few things. So it's a very useful library. It's still under development, but we are improving as we speak. Then we did a proof of concept as a VsCode plugin. So the nice thing is we are able to reuse the trace viewer base and the React components that we developed for the Theia use case. We needed to add some glue code around to be able to integrate these components into VsCode. So the widgets are running in web views. We had to implement the side panel and menus. But it's working, and you're able to open and connect to a trace server and open views as I showed before. However, certain features that we have with Theia APIs in the Theia extension, they are not implemented. We have a tracker for that, so you can follow what is missing and what needs to be done to be on the same level. However, this development is not our main focus at the moment. But if you're interested, contributions are very welcome, and we're looking forward to hearing about that. Okay, if we go back to the questions I asked, we get from users. So, can it run in the browser? So the new architecture and the new solution, yes, it can run in the browser. Theia provides the possibility to for that. Can we see result in Jenkins? Yes, it's possible to write a Jenkins plugin using the different components and show some result. It hasn't been implemented, but the opportunity is there now. Headless mode, yeah, having the Python client, and then we can do some scripting and trigger analysis without the UI, and that as well can be started from a Jenkins job. Custom graphs, yeah, with modern web libraries can be used since we are running a JavaScript application. So that's it's possible. So if someone wants to create a custom chart for with D3, that's possible. And finally, can it run with Theia or VsCode? Yeah, Theia I demonstrated in my demo, and VsCode is as well possible. So yeah, that's my presentation. That's all I had. If you have any questions, I will be available in the next few minutes to answer them. Thank you. Yeah, hello, welcome back. Thank you for listening in to, about my presentation. I got a question about tracing usually involves a huge amount of data. How is the performance of the TSP in passing the data between backend and frontend? So the heavy lifting of the calculation is done in the backend, and when we transfer the data from the front end, from the backend to the front end, the mechanism in place to query on a specific resolution and not request a huge amount of data. So that is one way to limit the data. A second way is that some caching done in some of the views. We request more data left and right to be able to navigate without going back to the backend. And yeah, about the amount of data, it really depends on the front end. We really need to make sure that the amount of data requested is not too big to minimize the serialization effort on between front and back and over the TSP. From your experience, second question is, from your experience with VsCode and Theia, how would you compare them from flexibility point? Do you expect that it's possible to have feature parity between Trace Compass on both, or are there things you can do in Theia but not in VsCode, or vice versa? So VsCode, and as we heard in the conference already, is more tailored to IDE applications and IDE use cases. So the APIs are really tailored for that. The views you can create is either you're using the APIs for creating tree views, or you're creating web views where you can basically put a web application in there and run. You have full control what you show there. However, if you want to need to communicate between multiple windows, you have to serialize data between the different views, and that makes it a more cumbersome to implement. We have seen that like on the left side, you have the left panel and then the views when you open. So you click on a trace, the view has to be open. And then if you have multiple views, you want to highlight things on the left side. So this synchronization was more tricky to do in VsCode than in Theia. The question about feature parity, I'm not convinced that we are gonna aim for feature parity. Trace Compass grew over many years, and there might be features in there, they are not used too much, so we might take the opportunity to look just that really needed and re-implement and remove features that are not really necessary. So it's really looking at that in that sense. So feature parity, I don't think we aim for that. And things about Theia and VsCode, as long as things are implemented in these Theia independent components, they will be available on VsCode and Theia. I hope this answers your question. Okay. No more questions. Thank you very much for your attention. Have a good rest of the Eclipse Con.